Hey everybody, welcome to the Ignited Podcast, Striking Industrial Automation Conversations. We're your hosts, I'm Travis Cox.
And I'm Thomas Burke.
And this episode is called Breaking the Gridlock, Redefining the Edge of Industrial Autonomy. Today we'll explore 4 real-world breakthroughs with Dan White, Director of Technical Marketing at Opto22, that are rewriting the rules of industrial edge computing operability and system architecture. From unified fleet management to hardened hardware built for extreme environments, this is what it looks like when operational technology stops surviving the edge and starts conquering it. Thanks, Dan, for coming on to the show.
Thanks for having me, guys.
Hey, Dan, let's start with some introductions. I know quite a bit about you. We've had the chance to talk quite a bit, but can you tell us a little bit about your background and, what's so good about Opto22?
Sure. Well, as Travis mentioned, I am the Director of Technical Marketing at Opto. I came up through the engineering side, so I've got an electrical engineering degree from Tufts University up in Boston. After I finished that, I moved down to Florida. I started working locally here at a HVAC manufacturer that makes marine air conditioning and refrigeration equipment. So I've kind of grown up on the industrial control side, first on the customer side, as I mentioned, working in a manufacturing setting, where we actually ran Opto22 snap pack systems to run environmental control chambers and various test rigs. Then on the sales side at Opto22, working directly with our customers, helping them to develop their own automation strategies before I took on this new role in our marketing team. So now I sit right at the intersection of the technology and the people who use it. I spend my days figuring out how to take what our products actually do on the plant floor and explain it in a way that's useful for other controls engineers like myself.
So, Inductive Automation and Opto22 have been working together for quite some time now. So can you give us some more background on Opto22 as a company and through the partnership that we have together?
Opto22 has been around since 1974, over 50 years now. The company was started by the co-inventor of the solid-state relay, and from day one, the philosophy at Opto22 has been open standards, openly available and commercially available technology, rather than proprietary lock-in. We were the first to pioneer PC-based automation in the 80s, Ethernet-based I/O in the 90s. We were part of the creation of the first OPC specification, and we've always stuck to that open approach ever since. Today, the flagship products are Groove Epic, our edge programmable industrial controller, and Groove Rio, which is edge I/O with IIoT software built right in. Everything is made and supported in the US, and most of our I/O is still guaranteed for life. Now, why we line up so well with inductive automation, it really comes down to a shared worldview. Both companies bet on open standards. Ignition is built around OPC UA, MQTT, unlimited licensing model, no per seat licensing games. We build hardware around those exact same standards. And the practical piece here is that Ignition or Ignition Edge, depending on the customer preference, is built right into our Groove Epic and one of our Groove Rio devices. So a customer can buy one of our boxes and they've already got an Ignition node sitting at the edge, ready to publish data without any extra middleware. Even though the products were completely independently developed by 2 separate companies, it's almost like they were designed together. And, that's not an accident. It's 2 companies making the same bet on openness and community, on sharing ideas and technologies.
Absolutely. And it's really the best of both worlds. You have greenfield, you can get brand new device with new sensors and all that coming in, along with being able to balance with Ignition on there, like the brownfield world. We can bring it together, one device can solve a lot of challenges that we're going to be talking about here today in the podcast. But before we get into the agenda, we have a segment that we do at the beginning is, this industry is filled, Dan, with tons of industry terms and jargons and acronyms. And we're going to be talking about a few of them here today. I'm sure of it. And so we do this little part that we're going to give you 4 terms or acronyms, and you got to identify which one is the wrong one. We call it real or fabricated. You got to tell us which one's the fabricated one. You ready for it?
Okay, ready to go.
So the first is IEC 62443. The second is MQTT. The third is PLAC. And the fourth is ISO 20237.
Ooh. I want to say PLAC because I've never heard of PLAC, but I think I'm actually going to go with that last ISO standard because I'm not familiar with that number.
Ooh, all right. Well, PLAC should have gotten me their first instinct because PLAC was the one that I threw in there because it's kind of like pack or PLC, but we put them together as that, it's not there.
That's kind of what I was thinking. I thought, oh, maybe this is just like a programmable logic and automation controller, and we invented a whole new term today.
Maybe you just coined a new one, Dan.
So for the audience, IEC 62443 is a cybersecurity standard.
That one I knew.
That one, of course, MQTT. Who doesn't know MQTT these days? Message queuing, telemetry transport, and ISO 20237. Not widely known, but it is the spark plug standard for IEC ISO. So that is where that came from. All right. Well, thanks for indulging us on that section there, Dan.
So, Dan, you already started to talk about the partnership between inductive automation and Opto 22 and how this has been going on for such a long period of time. So, and I understood that pretty well. But for our customers and the system integrators out there that are going to listen to the podcast, what's the value to the end user and the system integrator with this integration between Opto and inductive?
Sure. And the relationship works primarily because the products genuinely complement each other. Ignition is a fantastic SCADA and IIoT development platform, but it always needs good data coming in from the field. And so that's what we do. We get that clean, contextualized data off of the machines, whether that's, like Travis mentioned before, a greenfield machine where we're directly wiring sensors directly into one of our I/O modules like one of these, or whether that's from a third-party PLC or I/O device where we're using Ethernet connectivity or serial-based connectivity to grab that data and then publish it or expose it for ingestion into the Ignition ecosystem. So with Ignition Edge built right onto our hardware, along with various other options for OPC UA, MQTT, REST APIs, even legacy protocols like Modbus and so on, the handoff is pretty seamless. The customer isn't bolting two systems together and hoping that they talk. It's really part of one architecture.
So Dan, today we're going to talk about some different problems that you see out there in the field. So can you give us a sort of sense of the overarching of what these problems are and what customers are struggling with out there?
Sure. Now, at Opto 22, we've been solving real-time control and automation for many decades now. But one of the common threads that we're seeing today across a lot of these applications is the same. They've got data trapped in machines, and they lack a simple and secure way to get it out and make it useful. That classic use case is, a plant that's still writing things down on a clipboard. By the time that data gets anywhere, it's old, it's got errors. And so the transformation objective is really, today it's get me real live data that I can have confidence in, that I can make decisions on. And, what we solve is right at the edge of that problem. The dirty physical, every machine is different layer. Customers have different controllers, different ages of equipment, different protocols, and they all need it speaking the same language into a modern platform. Once you do that, all kinds of things open up. You get a unified namespace where every department can pull from the same live data source. You get real-time dashboards instead of clipboards. You get the ability to write new applications, potentially even AI-based applications on top of that data layer, because now it's structured and it's flowing. So that's the payoff. Not the dashboard itself, but the fact that the data is finally liberated, contextualized, and democratized for anyone to use.
Dan, I've known Opto for a long time, back in 1995 when, and the commitment that Opto and inductive automation have to open standards is just amazing. And as in my role when I created OPC, Opto was one of the founding four that really was part of the whole strategy. And I think this whole commitment to open standards also resonates well with the success stories that you're going to talk about today. So, I took a look. You have so many success stories that, customers using Opto 22 and using Ignition, but how did you pick these four that we're going to talk about today? I mean, what makes them so special to you?
I think, the reason I picked them was really the range, right? You've got, on one hand, you've got an automotive plant. Over here, you've got a gold mine. You've got a county water utility. You've got, a burgeoning data center cooling application. And these are four industries that, have almost nothing to do with each other on the surface. And yet they're all running the same fundamental architecture. Opto 22 hardware at the edge, Ignition for the platform, Open standards like MQTT, SparkPlug-B, and OPC-UA all tying it together. And that's really the point I wanted to make. This isn't a niche solution for one vertical. The same building blocks solved a safety problem in a gold mine, a latency problem in a water utility, a visibility problem in an auto plant, and a stability problem at a data center. When you build on open standards, the architecture travels. An integrator who learns it for one industry can apply it to another, and every one of these stories started small. One machine or one skid or just a few sites, but they grew because once it works and it's repeatable, expansion becomes easy. I chose them because they prove that the approach is general. If your problem is getting real data off your equipment and acting on it, it really doesn't matter much what industry you're in.
Yeah, and that's the heart of this, right? Is where we are today is to get access to the data, to make that data accessible, get the data into the right people's hands so that we can actually turn that data into insights. And you're going to see that with these 4 problems today. So let's get into the first one, Dan, which you have titled "Unifying the Un-unifiable," which is a problem that MTNA had. So can you give us an overview of that project, what the customer's problem and overall solution was?
Absolutely. MTNA, or Mori-Roku Technology North America, is a tier 1 automotive supplier running 4 plants across the US and Canada, and they all do the same thing: plastic injection molding for trim, moldings, spoilers, consoles, dashboards, any kind of plastic in a motor vehicle. And back in 2020, when they originally began their journey, they had this problem that I described. Their reporting was manual. Operators were literally updating numbers every 15 minutes on a clipboard. They had no real-time visibility into how their machines were actually running. Forget about, running applications on top of their data or AI. They were really at the ground floor, just wanted to be able to see what was going on in production. After COVID hit, there was everybody remembers there was a big supply crunch, and that supply crunch exposed how fragile their supply chain was. And so management at that time launched this initiative. They called it Vision 2030, with the goal of, by 2030, being able to feed all of their live data into a unified namespace. Now, but the catch was their machines. 20 to 30 machines per site, all different ages. These facilities had been, acquired by Mori-Roku Technology North America, so they weren't all greenfield from the beginning. I picked up a plant here, I bought another plant over there, and they all had a mix and match of PLCs and various controllers. So they started small and they started smart. Their IT vice president, Jeremy Johnson, didn't try to boil the ocean. He started with one machine and originally just added a little Raspberry Pi board. Now, it proved out the concept, but it was missing some of the things that they needed. It didn't have it wasn't industrial grade. It didn't have analog I/O. And of course, as a little computer with its own operating system, it wouldn't be as easy to scale and manage securely, essentially 100 little computers. So they were looking for an industrial platform, something repeatable and scalable. And that's what turned them on to Groove Rio. So for under $1,000, and I've got a little Rio right here on my desk and one over there behind me, but for under $1,000, they were able to add a Groove Rio to these existing machines, tap onto some existing signals, water flow, molds change signals, on-off cycles, and so on. And then they were able to use MQTT SparkPlug-B, which is built right into those devices, to publish that straight up to their cloud-hosted Ignition. In their case, they were using Microsoft Azure, running Ignition up there. So just by capturing those few key signals and publishing them to their UNS, by the end of 2022, they now have that running over 100 machines. It was about 4 months to scale that whole thing.
Yeah, you mentioned something really important during that, which is, we live in a brownfield world, right? Where there's still lots of these different kinds of devices that are out there. Companies like MTNA, they're struggling. They have lots of different vendors that are coming together, different protocols, some of which they can't even communicate to or don't have access to that. So what were some of these technical barriers that we had to overcome in this project with the fleet of multi-vendor solutions that they wanted to bring into a UNS, one unified system?
Right. And you said it right there. I mean, the hard part was never just one machine. It was that diversity of that fleet. some of those machines were still running fairly manual controls. Others had newer PLCs. Some had older PLCs with serial communication. And so, again, unifying that, what was the challenge? It was, how do we get all of this different data? This one from serial, this one Ethernet IP, this one's Profibus or Profinet. How do we get all of that data into a single system? And tapping into the actual control engines isn't always as easy as it sounds. A lot of those were delivered by OEMs. They may not even have access to the program inside of those. If they did, they may have to call out an integrator or an OEM that has access to it, that can really get into those systems. So, rather than trying to reverse engineer every single unit, every single molding machine, they were looking for something that they could just bolt on the outside, something small and easy. And that's exactly what led them to us. So they found one Groove Rio and they could just pop it on, and rather than touching any of those existing control signals, they just grabbed a few of the IO points that were critical to their operation, and that's what got them going.
Yeah, you could tap into all the IO that's there. You can leverage Ignition with all the drivers that are built into Ignition. You have all that data easily published up through MQTT. It makes it really, really easy. So, a big part of this for them is to avoid the kind of vendor lock-in, right? And that long-term operational flexibility and cost. So how does eliminating that vendor lock-in, change that mentality and the cost for companies like MTNA?
I mean, for one, I think it changes how you plan for the future. Right. A lot of existing control vendors, you sort of end up in this proprietary control stack. And when you're locked into that stack, every expansion becomes a negotiation with a vendor, whether it's, more hardware, more licensing, what's their roadmap, what's their timeline. But when you build on open standards instead, right, instead of I'm going to use this vendor, you say I'm going to use this technology like an MQTT, Sparkplug, or like an OPC. Now you can use equipment from any manufacturer that supports those open standards. So, MTNA can add a new machine tomorrow from any manufacturer, and they already know how they're going to connect it without re-architecting everything. If they end up purchasing a brand new system, maybe they can even start to specify, rather than a particular vendor, but a particular tech stack. Like, I want to make sure this machine supports OPC UA, or this machine supports native Sparkplug communication. On the cost side, the difference compounds over the life of the system. There's the obvious capital piece, $1,000 device here versus a full controller stack and ripping and replacing. But the bigger savings is downstream, right? You're not paying an escalating per seat license fees. You're not stuck buying only one hardware that works for your system because it supports some native protocol. You're not trapped when a vendor changes direction. MTNA put it well. They said, when they were working with us, and I mean us in the collective sense, both Opto22 and inductive automation, they said it felt less like product support and more like business vision support.
Yeah.
Wow.
That's what open architecture buys you, that freedom to move forward in whatever direction your business needs instead of whatever direction your vendor allows.
Yeah, now what I love about the story is that it's not vendors deciding what they need to do, right? It's them figuring out what their digital infrastructure looks like, baking it in, leveraging standards into that architecture, and now they can go choose best in class and overall scale and deploy these systems very rapidly to get a lot of value. And it's really exciting to kind of see, and that's the kind of vision that every company needs to have.
Absolutely. And I shared that use case last year at ICC on stage, and it was very highly and well received, I would say, by the audience there.
So Dan, we're going to go into the next one. We've got, got 3 more application stories to talk about. So the next one I call thriving in a hostile territory. I mean, it just has the right catch to it. So tell me, can you give me an overview of the Surety customer problem and what the solution was, and what were the challenges that they had?
Absolutely. So Surety, they're a veteran-owned systems integrator out of Spring Creek, Nevada. And I've been working with one of their owners, Chris Raymond. So back in early 2025, a gold producer in Nevada brought them in to modernize sump pump controls, what sounded like a fairly straightforward integration application. So this was sump pump controls in an underground mine. And underground, water control can literally be life and death. I mean, groundwater can it seeps in constantly. Blasting releases more, and it can rise, 12 to 16 feet in a single day if a pump fails and nobody knows about it. You can flood escape routes, submerge electrical gear and equipment. You've got real drowning and electrocution risk. So, I think your title of surviving in a hostile territory is spot on. So, the challenge there is that most of the systems they were running at the beginning of this project were just manual disconnected systems, float switches and pump starters with no visibility, no performance data, no way to tell if a failure was coming. And, when I spoke to Chris, he said, the conventional fix would have been they'd put a big PLC panel down there with a few racks of analog I/O, which of course is expensive, power hungry, and can be tough to maintain. So he came at it from a completely different direction. Instead of more hardware, he went with less, and they used more digital instrumentation in their case. So they used a lot of HART communication that they all fed back to a HART to Ethernet gateway to pull in a ton of data over a single pair of wires, right? Rather than separate wires running to various sensors. And they tied it all together with a single compact Groove Rio, just a little small edge device running CodeSys and running Ignition Edge. So, for this little, box, which is under $1,000 and rated for hazardous locations, they actually discovered Ignition through Opto 22. We have a lot of customers that find out about Opto from Ignition, but there's also cases where they actually find out about Ignition through Opto. And the more they learned, the more they loved. When they saw that, OPC connectivity, that they could connect to all these other various pieces of equipment and sensors, when they saw that they could use MQTT to support the store and forward, now they could push data up from underground up to the surface, and they could know that even in a very common condition like a cable gets blasted or run over, they would know that data would still get up there. In fact, they were able to, because of this sort of simplicity, they were able to even add a few other I/O. So the initial design called for the Rio, the physical I/O on the Rio, just to be used as an emergency stop, and then they had a bunch of other I/O points that were going to be left over. They ended up using those to add other parameters that they otherwise wouldn't have monitored, like environmental conditions, power quality. And by the time they finished that project, not only did the skid do everything that they wanted to do and more, but it came in way under budget. So it started as a project to upgrade 5 skids, grew immediately to 12 skids. And an integrator who hadn't heard of Ignition before is now a super fan. And by the way, will be with me on stage at ICC this year presenting some of their solutions. So look forward to that.
Yeah, definitely looking forward to that.
Excellent, Dan. So, this is one particular application, but what are some of the lessons learned and design principles that are critical when putting together a system like this in a failure-prone environment? So, it's not just what Surety did, but, what are the things that other customers could potentially, have to deal with, and, why did this solution work so well?
Yeah, and I think for Surety, a big piece of it was reducing failure points, right? If you've got a large I/O rack in this particular situation, and listen, large I/O racks work in lots of applications, but in this underground, tough to survive situation, the more analog I/O that they had coming back to the rack, that was more wires, more cables, versus running everything on a HART loop, which is essentially a 2-wire solution. So for them, a big part of it was just eliminating those failure points. The whole approach was, let's carry more data using less wires, so there's just physically less things to break. And then, the other thing, of course, is the hardware has to survive the environment that's listed on the spec sheet, not on a prayer. Rio is rated for -20 to 70 degrees Celsius, carries that UL hazardous location approval, which is a big reason Chris even looked at it in the first place. And when he saw the data sheet, as he likes to tell me, he said, this is it.
He knew that it was a very hazardous environment, and you had to have, the best of breed, solution to address this kind of, extreme condition. So, the other thing is, go ahead, Dan.
I was going to say one more big one, and one that, can't be underestimated, is these devices need to be self-sufficient underground. So, when you're underground in a gold mine, you have to assume the network's going to go down.
Yeah.
It's happening. So each skid has to be able to run independently on its own, make its own decisions, and most importantly, in this case, hold that data so that, when that connection comes back, you can backfill, and then you can have all your quality data and be able to make decisions on that later on.
So leading into that, we also talked about, store and forward redundancy. And how did that ensure continuity when the connectivity is unreliable or lost in this kind of an environment?
Yep. Well, and this was critical for them because their network certainly takes a beating, and fiber lines and copper lines get cut by blasting and heavy equipment all the time. So, losing visibility for a little bit is annoying. Losing all your data altogether for them was unacceptable. So, especially in situations like this where safety is paramount and where you're collecting, critical environmental data. So they really leaned in on the store and forward model. And, how it works in plain terms for the audience, when the network's up, RIOs publish their data normally into Ignition using MQTT. When that connection drops, RIO doesn't throw it away. It just buffers it locally. It'll hold it for up to 35 days if it has to.
Wow.
The moment that connection comes back, it backfills your Ignition historian, and everything gets sent back up to the central server. So you end up with continuous gap-free historical records, even though you had network outages along the way. You may lose a little bit of data, or you may lose a live view of that data during the outage, but they're never going to lose that data.
You never lose the data. It's there.
So you never have to go back and manually recover or manually record anything. So that's a great deal.
It's so critical, and it's for me it's fun to see. Like, we're not talking about replacing everything that's out there, right? Eating the whole elephant. We're talking about solving like just a couple small problem, right? Get a couple IO points and be able to start putting in an infrastructure where you can get that data up, do the store and forward. Once you see the value there, and you do it under $1,000, by the way, it can easily scale to a lot more. So it's a common trend you see in a lot of these solutions that you're bringing here today. So let's move on to the third one, and I really like this one a lot. This is we've titled "Killing the Lag," and this is with Genesee. So can you give us an overview of Genesee's, what their problem and solution is?
Absolutely. So, this is one of my favorite application stories because it really showcases the power of Ignition, MQTT, and Opto22 gear all together. So this was a water and wastewater utility. The Genesee County Drain Commissioner out in Michigan, they have 180 remote sites spread across 600 square miles, serving 21 municipalities. So those pump stations, lift stations, and all that report back to a central SCADA system. So the old communication architecture was a multi-hop licensed radio network running a polling model. So the master would ask a site for data, which would happen via a hop through a concentrator station along the way. And ultimately, it really wasn't an acceptable solution because, one concentrator failure would take out dozens of sites. And you ended up in situations where they were having so many communication alarms and failures that it was like the boy who cried wolf. They didn't know what was real and what was fake, and what was a real failure and what was just some kind of a communication blip. So it was completely unacceptable. Now, they thought of putting cellular out at those sites. They said, we can solve all these radio problems with a cellular solution. But the limitations there are if you're using that pull response model, you're racking up lots of bandwidth. And they were doing this at a few sites already, and they were paying fairly high cellular bills. So then, through the grapevine, my friend Terry Biederman over at Genesee, he learned about MQTT Sparkplug, and they said, we got to experiment with this stuff. So of course, with MQTT Sparkplug, sites publish the data instantly when it changes, rather than waiting to be asked on a constant pull response model. And so they paired it with Ignition. They replaced their old legacy SCADA system, and for new sites that needed PLC upgrades, they used our Groove Epics for some of the larger ones. For some of the smaller sites that maybe just had a pump or two, they were able to use Groove Rios at some of those meter pits and small lift stations. And for sites that even already had modern PLC, well, that was an application where they were using essentially our controllers just like an industrial PC, running Ignition Edge, using those third-party OPC drivers to get that data in, and then begin publishing that back up over MQTT Sparkplug to their central SCADA.
I want to dive into something you mentioned here, which has been a pretty standard architecture for these kind of remote systems, whether it's water, wastewater, oil and gas, or energy, or some of these where there's huge distribution of I/O. Where what do? We had a centralized SCADA system, and we pull over that telemetry network, right? Whether it's radio, whether it's cellular, whether it's satellite, there's all microwave. There's been all sorts of different networks that are out there, and you pull, but there are obviously some limitations with that, Dan. Like, what are some of those limitations that you have when you do it that way?
I would say the two big ones are lag, and of course there's that fragility of that network, right? In their particular case, when an operator would start a remote pump, sometimes it would take 4 to 5 minutes to actually get that data back to the SCADA system that pump had actually turned on. So think about that. You hit start, and now you're waiting 5 minutes just to know if it even worked. And sometimes the pumps, when they were running autonomously, they'd run on short cycles, maybe just for a few minutes, and SCADA would completely miss that. They wouldn't even see that because by the time the data got back to the SCADA, the pump had already turned off again. And so, and in their case too, you had everything funneling through these concentrator sites. So again, one concentrator failure would take out a dozen downstream devices at once. And so these communication failures were all over the place. They couldn't tell real failures from network noise, and they were burning overtime chasing failures that weren't even real.
Yeah, and this is where MQTT has fundamentally changed the OT space. I know we say this all the time. Arlen gets on stage and talks about it, but he single-handedly he has made these kind of architectures just so much more performant and so much more robust and reliable. We're talking about now being able to. You had PLCs at the sites. Those PLCs aren't buffering the data, but what you could do is put a Rio or an Epic right there and have ignition, all that, do store and forward, publish the data when it changes up to a centralized system versus pulling over the network. And ultimately now we've got much faster response times and more reliable data. We're not losing data. Same concept with the previous solution. We're store and forward. We're not losing that data that's out there. It just fundamentally has changed the landscape. And I think for Genesi, there were some measurable improvements that they business improvements because of this new architecture.
For sure. In fact, the numbers are great here because they're so concrete. At the converted sites, communication failures literally went to zero. They hardly ever have a communication failure now. Those converted sites, of course, run a cellular modem and either a Groove Epic or a Groove Rio, depending on the architecture. They went from hundreds of alarms a year on these sites, many of which required, like I said, overtime investigation to basically none.
Yeah.
And so there's real money there in labor alone, and it's a huge quality of life change for staff who are out there chasing phantom failures. But then there's the data cost, because as we mentioned, and Arlen likes to talk about all the time, and we all talk about, Sparkplug B only transmits by exception. So it just sends data when something changes instead of that constant polling. So their bandwidth dropped dramatically. And in fact, they were able to take measurements at one of the large sewer stations. They went from 50 gigabytes of cellular data a month down to under 1 gigabyte.
That's
and that
phenomenal.
efficiency then unlocks something bigger. Now cellular becomes affordable at these sites where it wasn't before.
Yeah.
So their CTO estimated that they could basically replace all of their radio sites with cellular now. And the cost of their cellular data plan would be roughly the same as what they used to pay for just a few sites. So small 2-pump lift stations that never even had full SCADA functionality, because of the way they're architected now, those sites can be plugged in and connected for under a couple $1,000s between a Groove Rio and a cellular modem. So up till now, they've tripled the number of connected cellular sites, and they're planning to continue. I think they've got about 45 of their sites upgraded as of our last conversation, and they're well on their way to upgrading all 180 of those remote sites.
So it's really all about the architecture of publishing by exception, and publishing only data when it changes. So it really streamlines the operation. So they're only seeing the data that they really need. And it's just perfect. So, and you're right. They don't have to send not sending data that they don't need, right? It's only sending when it changes. It's the perfect architecture.
And not to mention, we were saying earlier, if I turn a pump on, I get instant feedback.
Yeah.
I'm not having to wait. for the polling cycle to come around.
No latency, no delay.
Absolutely.
So the next one is what I call coordination at scale, and it was the Nautilus project. So can you give me an overview of Nautilus customer problem and the solution there, Dan?
Sure thing. So Nautilus Data Technologies, they do liquid cooling for data centers, which of course is a hot area right now. See what I did there? But these AI servers throw off way more heat than traditional ones. And so Nautilus has an interesting story. They actually started as an operator, not as a cooling manufacturer and vendor. They built and ran their own liquid-cooled data center back in 2019 in Stockton, California. It floats on the San Joaquin River and uses the river itself as a heat sink. So, at its core, it's still a process control application, something that our products have done well for years and years, but so do a lot of other PLC products. But what I really like about this story is that they didn't just default to the old playbook and just grab some off-the-shelf PLC that, because that was the old conventional approach that everybody was doing. Not naming any names, but they didn't want to lock themselves into a proprietary controls package with extra licensing and proprietary communication protocols and the like. So for their product, the one that we're talking about today is the EcoCore FCD. It's a facility scale cooling unit. They built the controls on an open platform, our Groove Epic, which they had already used and trusted at the Stockton site. So their architecture uses two Epic processors, one that's embedded in the cooling unit itself, and then and that runs CodeSys for real-time control, and then another supervisory controller that's running Ignition Edge that can communicate to various controllers so they can all coordinate together. They use peer-to-peer OPC communication to talk right there, and then they use MQTT data to get that into their SCADA. So the supervisory unit, which is running Ignition Edge, gets that data to flow up to a central ignition gateway where the operators use ignition perspective. So that's where they're able to monitor everything and adjust set points remotely. They didn't choose the "we've always done it this way" approach. They chose the "let's blaze our own trail" approach because it's genuinely a better way to build an OEM cooling system.
So Dan, what are some of the key challenges that they faced? I mean, what you're trying to do is you're synchronizing multiple autonomous and semi-autonomous, machines at scale. What were the challenges that they had to make that a reality?
Yep. So, liquid cooling, that means pumps, valves, sensors, long piping loops, and all of it has to work in sync. So a small shift in one place can propagate through a whole hydraulic loop and can affect cooling across an entire room. A new OEM product means learning on the job. And when real issues popped up, like I recall there was one issue where they were having timestamp synchronization issues, they had the support from Opto22 engineers to help solve those problems and push through those.
Wow. It's just phenomenal. So we talked about coordinated control. So how does it unlock value that, independently operating machines cannot?
Right. I mean, you can wire up each component individually to do its job and call it done, but in these kinds of liquid cooling loops, the components aren't really independent. Even if you wire them independently and coordinate the control independently, everything is coupled through the liquid. So if your pumps and valves are doing their own thing and they're not talking to each other, you get instability, pressure swings, oscillations, and sure, when the IT load changes, which it does constantly, the system can't adapt cleanly, and isolated controls can hold a single set point, but they can't keep a whole hydraulic loop stable across a wide range of flows and pressures. So by having that real-time controller and a separate supervisory controller sharing data, their modular cooling systems behave as one unified system instead of a collection of parts. What Nautilus is selling here is a cooling system that stays predictable and stable under real changing loads, and that's only possible when the pieces are orchestrated together rather than running blind next to each other.
And all these stories, right? What's in common is the open standards approach. It's leveraging, we're leveraging Opto22 and Ignition, which are best in class in their categories, but we're putting together with an architecture that fundamentally is vendor agnostic, is scalable, is going to provide them a ton of value. And so we really appreciate you diving into each of those stories there and showing us, what's possible. What's the art of the possible? Start small and it's going to scale. It's going to grow. You're going to solve real problems out there. So Dan, what does the future hold, right? What do you think, for Opto 22, for yourself when it comes to maybe AI, things like that? What do you think about in the future here?
So I'm genuinely optimistic about where this goes. And I think, it still does come back to this theme that, open standards are winning. The whole industry is moving toward this model. Data published by exception, organized in unified namespaces, accessible to whatever application needs it. That's really the foundation that everything else is built on. And it's exactly what we've been betting on for 50 years. And I think in terms of, the future of the products, it's all about scalability, things like software containerization. And we're really doubling down on that with our latest and greatest products that'll be hopefully announced by ICC this year.
Ooh, I'm looking forward to that. That sounds pretty good.
Dan, thank you for sharing these incredible, 4 solutions that you've talked about today. I know that our audience is going to, we're going to give them the opportunity to dig more in depth. We're going to provide links to these as part of the podcast. But it really shows how the whole ecosystem, and I'm so excited about the work between inductive automation and Opto 22 and the commitment to open standards as Trust, really talked about. And we basically have solved real problems and really helping customers achieve their digital transformation. So thank you again for sharing these stories.
Yeah, and we'll, like I said, put the links on there. But Dan, how do people get connected to you?
Well, the easiest thing would be go to opto22.com. But here's what I'd really like to point people towards, because it's a little unusual in our industry. Our pre-sales engineering is free. Our product support is free. Our online training is free. Not a trial or a teaser. You can actually call and speak to an engineer before you've bought anything and talk through your application. And they'll help you figure out if it's a fit. Every one of these case study customers started with a conversation just like that. So my advice is, don't overplan it. Just, reach out, get on our website, opto22.com, check out our Opto video on YouTube. It's not hard to get a hold of us. And so like I said, talking is free.
Well, perfect. Clearly your company provides a strong leadership position, helping companies successfully use your technology. And, we're really excited about where the future holds with all this. So thanks again for coming on the show.
Thanks, guys.
And as always, subscribe to Ignited on YouTube, Spotify, and Apple Podcasts so you never miss an episode. Thanks, everybody, and we'll see you next time.